Hello all. Two previous lectures actually proved that binary system is universal technology in mathematics that allows us to make calculations the same way as we do calculations in decimal system. But it more relationship with the computers because the computer element is binary. It is a switch, and switch can have only two states, 1 and 0. This device named binary. But so far I would like to speak about how computer understand textual information and how it represent and send and receive textual information through the binary code, through the binary system. Folks, as you remember, I told you that number of combinations dependent of number of bit is equal q quantity of combinations 2 in the power of n, where n is equal number of bit. To remind you, the bit is binary digit. It is abbreviation, binary digit. To understand how many binary digits is involved to encoding, we need to put the table and to see how many binary digits is involved in encoding. I can create code with 5, 6, 7 bit, but basically code created with 8 bit, that is pretty standard. And when I draw the table for 8 bit, which is placeholder for 8 bit, we call it 1 byte. By the way, memory of the computers could be measured in number of megabyte, gigabyte, and terabyte. And I will remind you quickly that 1 MB, 1 megabyte, is approximately 10 in the power of 6 byte, and 1 gigabyte is 10 in the power of 9 byte, and 1 terabyte is 10 in the power of 12 byte. So byte is universal measurement unit for informational storage. This 8-bit is a placeholder as a memory for 1 byte. I can place different bytes here, like this one, 0110, 1100, and that will be 1 byte placed in this memory cell. But I can put different bytes. The smallest byte that I can place here is 0000. 0000, all zeros. How many? 8 zeros. Then I can count 0000, 0001, 0000, 0010, and so on and so on and so on, like I did before. And eventually my byte will look like 1111, 1110, and the last one 1111, 1111. You can check, as I told you, how to convert binary code into decimal. That will be 0, that will be 1 in decimal, this is decimal, that will be 2 in decimal. I do not want to repeat the technology, and I know that the last one will be 255 and previous is 254. Beginning from 0, number of bytes that could be placed in a 8-bit placeholder is 256. So 2 in the power of 8, this is number of bit, is 256. Now let us speak about encoding. In the computer there is no way to put the regular glyphs of our letters. What is glyph? Glyph is the form of letter. That's A is this kind of, and A is also this kind of, and A is also this kind. All of them are A, and we call this the form of glyph. Glyph is a form, structural form of a letter, of character. I have 26 small letters, 26 big letters. I have kind of symbols like this. We call it punctuation. What else I do? I have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay? I have arrows like this. I have arrow like this. And many I have slash, this backslash. So folks, all of these characters that I need to use in the book creation is about 255. 255. Question: how am I supposed to encode it in the computer? Inside of the computer, there's only binary memory chip. Binary memory chip can only memorize binary code. So people said, no problem. Let us substitute the character with its binary equivalent. For example, we will make A like its binary equivalent. That will be 0, 0, 1, 0, 0, 0, 0, 1. For example, I do not remember exactly. B will be different. Let's say 0, 0, 1, 0, 0, 0, 1, 0. C could be different, like this. 0, 0, 1, 0, 0, 0, 1, 1. And so we can substitute all of these characters with its binary value. But folks, this binary value must be the same for the device and human who send and on reception. That must be the same code table. So American code table was designed in 30s, and people who designed it named it ASCII code. ASCII code. ASCII code is a standard code for information. American Standard Code for Informational Interchange. And this table, you can find code table inside of the topic where you watch this particular video. ASCII code. So folks, this ASCII code only for Latin-based languages like English, French, Spanish, Portuguese, Italian. And I can say in this language we have encoding table that use 1 byte per character. 1 byte per character. Okay, my friends, we spoke about encoding and how ASCII code could represent 256 characters of English language and relative languages that use Latin scripts for presentation of the letters. But how many bits we need to use to encode one character? Before I finish with last explanation, I said ASCII code, American Standard Code for Informational Interchange, utilized 1 byte per character. 1 byte per character. 1 byte is 8-bit, but according to the formula that we have, Q, quantity of combinations for 8-bit, we can see 2 in the power of 8, it is 256 unique combinations. So this coding system, ASCII code, could encode only 256 characters. But folks, when internet started developing and people continue works with international communication, they figure out that there are many other languages but English, and people use different characters. For example, Russian language used letter U, Hebrew language use letter Lamed, and Chinese language use aglyphic images for the letters. By the way, Chinese language use more than 3,000 aglyphs for their letters. In Russian language, we have 33 letters in alphabet. So, how to actually use encoding when we have just 256 characters? It's actually impossible. So what people designed, they considered that 1 byte per character, 8-bit per character, is not enough for encoding. This is 1 byte. And then they said we need to use more bytes, and they dedicated 2 bytes per 1 character. 2 bytes. This is 1 byte, this is another byte. Totally, this is 16-bit. 16-bit. Now we need to figure out how many characters we can encode when we use 16-bit. Folks, Q, number of combinations, is equal to 2 in the power of 16, or 256 by 256. That is, if I remember, this is 65,536 characters. Characters could be encoded with 2 bytes. This new code, folks, it's different from ASCII. Get the name Unicode, like universal code. Unicode. And this code is in use for all languages on the planet Earth. This code includes Chinese, Cantonese, Japanese, Ethiopian, Zulu, Russian, Bulgarian, Serbian, Catalonian, and all languages that you can imagine. All languages. So, Universal International Code, Unicode, for the internal use, for English-speaking countries, ASCII code is good to encode it.